Okay, guys, today we're going to be talking about verifying trig identities. This is section 7.2, and basically all these, what an identity is, you've got a formula on one side, you got a formula on the other side, and they're actually equal to each other, even though they look very, very different. And so what we're supposed to do is to take one side and transform it, just staying on one side, into the form that's on the other side. Sometimes that's easy, sometimes it's a little more complicated, and so in order to maybe cheat just a little, you'll work on one side and get it down to something, work on the other side, get it down to the same thing, and so once you have the two the same, then you can reverse the order. Anyway, let's take a look at example 1 on page 431. It says verify that secant squared x minus tangent x cotangent x is equal to tangent squared x is an identity. In other words, the left-hand side is exactly the same as the right-hand side. We've got to go through and show that somehow. Well, the very first thing that we want to do is to look at things that we've learned previously, and in this case the left-hand side is got a whole lot more stuff to it. So this is the side that we want to start with, and we want to try to make it be a tangent squared x. So I'm going to take the secant squared, just bring it down, minus. Now tangent and cotangent, if you put them back in terms of sine and cosine, well, tangent is sine of x over cosine of x times, and then cotangent would be cosine over sine. But again, when we write it like this in terms of sine and cosine for these, the sines divide out, the cosines divide out, and so what this is a 1. So I'm going to write this as secant squared x minus 1. And now then, this is one of our key trig identities that we've had previously. In fact, this is one of our Pythagorean trig identities. We saw something like this: cosine squared x plus sine squared x is equal to 1. And I said there were two other trig identities that were Pythagorean trig identities, but this is the one to remember, because this is the x squared plus y squared equals 1 from a unit circle. You can get the other two by just dividing by whatever you need. Well, since we've got a secant here, if you wanted to get secant, you would somehow have to have 1 over a cosine. So I'm going to divide both sides here by cosine squared x, term by term by term. Now this is not part of this problem, but we're just using this, and then we'll go from here. Well, again, this is 1 cosine squared over cosine squared plus tangent squared is equal to secant squared of x. Now, if you look at this line right here and the starred line up above, you see the only difference between these is that the 1 is on the opposite side. So if we take this, we can see that these are now, we could actually write this as tangent squared x. And that is equal to the tangent squared. And this one's kind of nice because we didn't have to go through and change anything on the right-hand side. We just worked on one side, and we got them equal to each other. You can go from the third to the fourth lines fine. All right? So that's example 1. Let's take a look at example 2 on the next page. Again, the directions here. Verify that the two expressions for L of theta are equivalent. In other words, show that this is an identity. Let's take a look at this one. It's 7 sine of theta plus 5 cosine theta divided by sine theta cos theta. And that's equal to 7 secant theta plus 5 cosecant theta. Okay, these two things are equivalent. They've already told us that. We've got to go through and find some way of making these two things be equivalent. Now, the textbook goes through and works on the right-hand side. I think it's easier to work from the left-hand side and simplify, but it doesn't matter. Whichever way that you see it, you do it that way. I'm going to go back and use some basic rules of fractions right here. You've got two terms in the numerator. Well, you can split them up and separate them over their different denominators. So I'm going to put 7 sine of theta over sine of theta cosine theta plus 5 cosine of theta over, same denominator, sine theta cosine theta. Now again, separating it like this, you can see the factors that are going to divide. And so we can take the sine of thetas in the first fraction. We can take the cosine thetas in the second fraction, divide those out. And so what we have is 7 over cosine theta plus 5 over sine theta. Now we want it, again, we want it to look exactly the same as the right-hand side. Well, I'm going to write this 7 over cosine as 7 times 1 over cosine theta. Plus, and then I'll write the second one as 5 times 1 over sine of theta. And the reason I'm doing that is because what is 1 over cosine? What's the reciprocal function of cosine? Well, that is the secant that's right over here. What's the reciprocal of sine? Well, that's the cosecant that's right there. And so now we can write this as 7. Again, C goes with S, so this is going to be secant theta plus 5 times, again, cosecant theta. And now those are equal. Okay? So the first two are not too bad. Let's take a look at example 3. Example 3. Again, the direction to just say verify. So verify that sine theta or sine of A, that's probably better. There's been some problems with theta before. Divided by cosecant of A plus cosine of A divided by secant of A is equal to cosecant squared of A minus cotangent squared of A. All right. Well, in this case, I'm going to follow pretty much what the book does here. The cosecant and the secant here and here, I really don't like working with. So I'm going to put them back in terms of what they are with sine and cosine. Well, this is going to be sine over 1 over sine of A, because cosecant and sine are reciprocal functions of each other. So I'm just rewriting it in that form. We're going to do the same thing with the second one. This would be cosine of A divided by, well, again, instead of writing secant, I'm going to put 1 over cosine because that's its reciprocal function. Again, here and here. Those are equivalent expressions. They're just reciprocals. But now then, sine divided by 1 over sine is, well, how do you divide by a fraction? You multiply by the reciprocal. The reciprocal of 1 over sine is sine. So this is sine squared A plus cosine squared A. Now let's think about this for a second. This is back to one of our original trig identities, the Pythagorean trig identity. All of this is equal to 1, right? But now it's not really looking the same as what's on the right-hand side over here. So let's cheat a little bit and work on the right-hand side, right? In other words, we've got this, it's equal to 1. If we can somehow come on the other side and work with this, we may be able to do something with this at the same time, and it's a little easier. So let's take this cosecant. From one of our 3 Pythagorean trig identities, this is going to be 1 plus cotangent squared of A. That comes directly from this. All right, there were 3 Pythagorean trig identities. This is one of them. Minus cotangent squared of A. Well, we can go ahead and jump all the way down to here now. That's equal to 1. Because they equal the same thing, right? Even though we didn't just stay on one side, because it was a little harder to do that, we worked on both sides and got them equal to the same thing. They're both equal to 1. They're both equal to each other then. All right, let's take a look at the last example. Example 4. It says find the numerical value of one trigonometric function of x if cotangent of x divided by cosine of x is equal to 2. Find a numerical value. Okay, it doesn't say multiple, although there could be multiple values. We just want one. Well, again, I don't like working with the cotangent, so I'm going to switch it, change it back into cosine and sine. Well, cotangent is cosine over sine, and that's being divided by cosine of x, and I'm going to put that over 1 now, writing that as a fraction. Well, again, for division by fraction, you take 1 in the numerator, and then you multiply it by the reciprocal of the denominator. And in that case, it's going to be 1 over cosine of x. Let's take a look at this. Here the cosines divide out. And so we have 1 over sine of x well, again, what is 1 over sine of x? It's a reciprocal function of cosecant. And so we finally have what our directions said, find a numerical value of one trigonometric function. We have cosecant of x is equal to 2. Now that's the answer that the book is giving, because that is one relation. What I like to do is this. I'm going to put the 2 up here and look at this 1 over sine of x. Take the reciprocal of both sides here. But see, I still don't like working with cosecant. That's a true statement right here. Cosecant of x is 2. That's all you got to do. But I like leaving it in terms of sine and cosine, so I'm just going to take the reciprocal of both sides and say sine of x is equal to 1/2. Well, now that's a different trig function. but it's one that we know something about. I don't know the cosecants, but I do know the sines and cosines, and when I've got a sine that's equal to 1/2, that makes me start thinking, what's my radian measure there? What's my degree measure? Well, this would have to be, let's see, sine 1/2, looking at the clock, 1/2, that's pi over 6. Or, if you continue around the clock, because sine is the y value, that would also be, x is 5 pi over 6. And then if you wanted all of them, you just add 2 pi n to both of these and get them all. If you had it in terms of degrees, the first one would be x is equal to 30 degrees. The second would be x is equal to 50 degrees plus 360 n, right? And you could get all the values there. They weren't asking us for the value of x, okay? They could have. They could have. All they were asking us for was what this left us with here, one function. However, I got to say, I like this function a little better. You can use whichever one that you want. We could also say that cosine of x has got to equal root 3 over 2. That's another trigonometric function, all right? So once you've found one, you can find them all. So that's what we were going on here. But again, you can stop with the first one there if you so choose. Okay, guys, the assignment on this section is on page 434. Let me just write it up here. Page 434. Let's take all the odds starting from 13 down through number, 35? Yeah, that's it. Just the odds. And that's it for section 2. Looking ahead, we've got to finish sections 3, 4, and 5 before we get to the exam. Sum and difference formulas, and then double angle and half angle forms. There will be a lot of memorization in those. It's not difficult, it's just things that you'll have to know. And then section 5 is using equations. So there's no new stuff, it's just actually then you have to go through and solve. Anyway, go ahead and get busy on these.